I should also say you don't have to be a mathematician to understand this, but in a sine wave, you know, we used to have what this mathematical field used to have, I guess we still do, called trigonometry. I kind of liked trigonometry, at least from what I remember. And I remember we were always looking at things like a triangle and trying to figure out what these angles were. And we'd use things like sine and cosine and tangent to do all that. I'm sure all of you just love talking about this math again. So I just took you back to junior high. Anyway, when we think about that, I'm bringing this up to just kind of get an idea of why we have these measurements between distance called 360 degrees on a sine wave. So basically when we see the peak, the positive, and the next peak, the next positive signal, the distance in between that we're going to say is 360 degrees. Now, that, by the way, it does not tell us what the, well, it begins to help us understand the wavelength, because the amount of time it took to get from the one peak to the next peak or I should say the number of times you do that over a second tells us what that wavelength is going to be. But technically, we call that frequency. A wavelength really is just the distance between the two successive crests of that signal. How many times that happens is where we would come up with the word frequency. Now remember, because of AC, alternating current, that we can have this continual change between a positive and a negative, and if the power source were to change that current, it could make the wavelength longer or shorter. That's the other reason why we like using AC.